Right, team, exercise 6E. Why did I jump to 6E and not do 6D and in between is because I find exact values and symmetry properties link better to solving. So if you know your exact values, you know your symmetry properties, you can then solve. If you can solve the equation, you can sketch. That's how it usually works. So today's lesson is more, again, gives me the opportunity to test your exact values, gets you to practice your symmetry properties again. So 6E is good for that. And then next week, after you've got a bit of practice over the weekend, then next week I don't see you on a Tuesday, so I'll see you next Thursday. And by that point, hopefully, we can then move on to graphs and see what we can finish by that point. Okay? Let's start here. You're going to be solving for trigonometric equations. Let's take the example of y equals sine of x is equal to half, right? When we're solving sine of x equals half, I've drawn a picture of what a sine graph looks like. This is what a sine graph looks like. It'll go infinitely to the right and it'll go infinitely to the left. It oscillates. This is one cycle of a sine graph that I'm highlighting. That's a distance from 0 to 2 pi. That's one cycle, right? And what we know is that y is at 1 and negative 1. Again, the unit circle. Sine represents which one again? X or y? Y. So we know that the y values in a unit circle, so if I look at a unit circle, the y values range from 1 to negative 1 as you move around the circle. So no matter where you are on the circle, your y value, the height, the y value can only start from 0 and get a maximum of 1 before it gets back to 0, goes back to negative 1, it goes back to 0. And that's what the graph is demonstrating, right? What we know is that when we say sine of x is equal to half, meaning sine of what angle, that will give you a y value of half. So if you look at it in a unit circle, what I'm saying is, if this is 1, half must be somewhere there. That's the y value of half. So where on the circle will I have a coordinate where the y value is half? Well, there's only 2 points. Must be here, where you have the y value is half, and the other point must be over here, where the y value is also half again. When we say x, well, x represents the angle. So to make that line there and to make this line here, we can then ask ourselves, well, what is the angle that is required? So starting at 0, and I'm moving a certain angle, so sine of that angle, sine represents the y value, so I'm looking at this height. This is what you're really saying. That height of that triangle there, Sokotola, opposite over hypotenuse, which we know is 1. So whatever that height is divided by 1 is itself. We know the height is half. Your job is to find x. Now, same thing. Going back to your exact values. Think about it. You can use my hand method. What value will give you, so sine of what angle gives you half? This finger. No, so I want one finger. So I want to remember the formula for the hand method. Root of 1 is 1 and then divided by 2. So it has to be this finger. Which angle is this finger? The index finger. Pi and 6, 30 degrees. Okay, so I don't care how you learn it, whether you learn it through my hand method or you learn it through memorizing a chart. You have to know it. Okay, that's your goal. By the end of next week, I want you to know your exact values, like your times tables. Okay, so when I ask you something like that, sine of what will give you half? The answer is 30 degrees or pi on 6. That's the answer. So when I'm doing my hand method, I'm saying that sine, I just needed one finger, so the root of 1 divided by 2, that's how you're going to get half. So I need to drop this finger down, and that's your pi on 6 or 30 degrees. So remember, go 0, 30, 45, 60, then 90. Okay, so it's that index finger, and I've got one finger on my left, which represents a sine, because there's 3 fingers there. Yeah? So now I know it's pi on 6, so I know, remember, pi on 6 is the distance around the circle, which happens to be 30 degrees. So x is 30 degrees, but the distance outside of the circle, this is a distance of pi on 6. Here, this is 30 degrees. That's what we're saying. We're saying pi on 6 is equivalent to 30 degrees. So if that's 30 degrees, now we can use symmetry properties and we can say, well, The triangle is exactly the same. If I have 30 degrees here as well, that means this is also pi and 6. So from here to there, that distance is pi and 6. That's 30 degrees. That height must be half, just the same way. So the solution for sine of x equals to half, only within one revolution, which is 0 to 2 pi, from 0 to 2 pi, starting at the angle of 0, and I go all the way around the unit circle, come back at 2 pi. So one revolution is what this section represents. And I'm saying there should be two answers here. Let's look at the radians. You start off at 0, and you're moving up by pi and 6. So that distance is 0 plus pi and 6. I should have 0 plus pi and 6 here. And my second one, yes, Albert? Beautiful. This is starting at pi, and I'm going back by pi and 6, so it should be pi minus pi and 6, which simplifies to pi and 6, or 5 pi and 6. So we'll look at the graph, the sine graph that I've got for you over there. What we're saying is, as this is oscillating, when is it equal to half, which is 0.5? And you can see this intersections right here. There's 2 points. 2 points on the graph that literally corresponds to what we just said. This is likely 30 degrees for pi and 6. And then 180 take away 30 is 150. So when x equals to pi and 6 and 5 pi and 6, those two is when you get half. But I can see that obviously there are many more cycles. There's another 2 over here, there's another 2 over there, and it will keep going. That's why they have to specify a domain. Otherwise, there are infinitely many solutions. Your job today is to be able to break out not just from 0 to 2 pi, it could be from 0 to 4 pi. There could be a dilation factor to the x. Could be a dilation factor to the y. Your job is that you can solve it. Whether I do translations, dilations, or reflections, you should be able to solve it. And it comes with, again, first step is you need to figure out the angle to get a certain value. And that's your exact values and symmetry properties. Okay? So, let's do today's first example. And then the second example should be a bit of a more combinations and see how I solve it. There are many ways to solve it. You might have learned it differently from your previous teachers or your tutor. I don't care what way you learn as long as you know how to do it. And then it's fast and efficient. Yeah? So here we go. Let's do the first one over here. Okay. Find all solutions for 2 cos of x is equal to root 3. The domain is 0 to 4 pi. So I'm just looking at the unit circle. Remember, this is 0, this is pi on 2, and this is 3 pi on 2. All right, here we go. To solve x, just like how you've been doing it since year 7, inverse operations, get rid of everything that you don't need and you want to get x. I don't need this times 2, so I'm going to divide both sides by 2. 2 cancels out. Cos of x is equal to root 3 on 2. I want x. I don't need the cos. So the opposite of cos is cos inverse, or inverse cos. So here I then say, well, let's do the inverse cos left, inverse cos right. These cancel out, and I get x is equal to cos inverse of root 3 on 2. And that's equivalent to you saying cos of what angle gives you root 3 on 2. For that one?
Yeah, and also because say you had something else, say on x, it was x plus 6 times.
It would then tell you what well, it's true, there is a restricted domain. What I'm doing here is I'm just getting the general answer, and then I restrict it afterwards. So that's why I'm saying some of you might learn it differently. How I used to learn is that you had to restrict the domain first, and then you work with that. And I taught that in the past, and a lot of students got confused. So I stick to this method now. I just stick to it. Forget about the restriction. Get the solutions first, and then we apply the restriction afterwards. It seems to be easier for students to pick up on. Yeah? All right, team. So let's work out just from our exact values. We're trying to find when is cos equal to root 3 on 2. So if you look at the unit circle, cos represents your x values. X value starts here, root 3 on 2, but remember the maximum is 1, so root 3 on 2 must be somewhere over here, right? So I'm saying, when will my x value be root 3 on 2? There's only two parts of the circle where you can get an x value of root 3 on 2. It's right here, that's 1. So root 3 on 2 corresponds to this point, but it also corresponds to this point down here. That's the only 2 points on the circle where you have a positive root 3 on 2 as your x value. I don't really need my y at the moment because I'm looking at my cos, the cos values. So cos is root 3 on 2. The question is, what is the angle? This is where you go back to your exact values and you ask yourself, if I have a triangle in the first quadrant, what angle, cos of what angle to get that length of root 3 and 2? Let's test your memory now. Let's go with Samuel. Cos of what will give you root 3 on 2? So you need 3 fingers. Yeah, so the formula is root of something over 2, so that means you need 3 fingers for cos. So which finger should you put down? Yeah, very good. So you drop down the index finger. That represents the 3 fingers you need for cos. So it must be 30 degrees or pi and 6. So I know the distance is pi and 6 on the outside, and the angle must be 30 degrees. Okay, so the angle's 30 degrees, angle's 30 degrees here. And that's pi and 6 up or pi and 6 down. Now, like what I was saying to Patrick there was that I will then just work out the solutions between 0 and 2. Just get some solutions first and then work the restrictions later. That's how I do it, and I find that's the easiest way to teach the students. There are some ways where you can restrict the domain first, and you just work within that. If you're strong with the algebra and you're quick with that, do that. But this is how I do it. Okay, so I find the first 2 solutions. Here we go. Starting off at 0, I can go up by pi and 6. So the answer is x can either be 0 plus pi and 6, because you know it had to be pi and 6 through our exact values, or going downwards. Now you can choose to say it's 0, take away pi and 6, or you can say 2 pi, because 2 pi is the same spot, take away pi and 6. It's up to you. For me, I like to work with positive numbers, so 0 to 2 pi, I would have wrote 2 pi minus pi and 6. So you've got 2 solutions. Let's say 2 pi minus pi and 6 rather than 0 minus pi and 6. Either way works, doesn't matter, yeah? Yeah, I know. So that's what I'm saying. Get the first 2, and then we apply the restrictions later. Yeah. So this is what I find that seems to be the easiest to start off with. If we just get the first 2 solutions in one cycle, then you can apply the restrictions afterwards. And that applies even when you make it more complicated, like the next example, you can still do what I'm teaching you, and it should still work. Okay, so let's do this bit here. The 2 possible solutions that if I just had cos inverse of root 3 on 2, you have pi and 6 and 2 pi minus pi and 6, which is, what's that? That's 12, 11 pi and 6. Okay, so 6 times 2 is 12. 12 take away 1 is 11 pi and 6. So I got 2 answers here. But like Albert just mentioned, the domain is 0 to 4 pi. Now you can follow the unit circle and then write out your next ones. Some of us can do that really well, some of us may not. If you can't use the unit circle, then here's another method. Okay, this one I find that most students pick up on. Remember from last year, how do you find the period of sine and cosine functions again? What's the formula? 2 pi and n. And that really just comes from the fact that 2 pi is one cycle, and then there's a dilation factor of 1 on n, which is what you learned from chapter 3. Yeah, so the number that multiplies to x is the reverse when you do the transformation. So 2 pi and n, what's my n value at the moment? 1. It's the coefficient in front of x, what I'm multiplying to x. So therefore, it must be 2 pi on 1, which is 2 pi. So what that means is, for each of these points, if I want to know the next cycle, I'm literally just adding another period. So from this point here, if I started off at this point, I just need to add 2 pi to get back to another one, same position. Or if you think about the graph, if I started at this point, I just need to add another cycle to get back there. So that's one cycle. Second cycle. Third cycle. Okay, so for those who find working with a unit circle hard, this is the other method you can do. We know that we're adding on 2 pi for every distance for each point. You've got 2 points. Well, this is out of 6. You can write 2 pi out of 6 as 12 pi out of 6. Now it's easy to figure out. If you want to know the next one is add on 12. Because we know that 2 pi is the distance, but in terms of denominators of 6, it must be 12. So 1 plus 12, I've got 13. If I want to know the next one, add another 12. 25 pi on 6. If I want to know the next one, add on another 12, and you get, what's that, 37. That gives me just the 1 point. But notice there's a pattern. Pi and 11 pi is only a difference of 10. So that means if I know 13, the other one must be 23. If I know this is 25, there's a difference of 10, so this must be 35 pi and 6. If I know this is 37, wait, that doesn't feel right. Something's wrong. Is that right? Oh, that's right. Yeah. And then like that. So you can see I can keep going forward or I can go backwards. But all I did was I found the first 2 solutions and then I just applied the period. You just add, subtract until you get the domain you want. Now you said you want from 0 to 4 pi. Well, clearly, if I subtracted 12, it'll be negative, so it can't be. The smallest value clearly is here. So 0 to 4 pi. Now 4 pi, if I had to write it in terms of 6, it has to be 24 pi on 6. 4 pi is equivalent to 24 pi on 6. So that means it gets cut off here. From 0 to 4 pi, these are my possible solutions that you can have. That is what I found in terms of teaching. I found this is the easiest way to teach it. Find the solutions, and then trial and error your periods until you get them all. And all I did was just add and subtract. That's the easiest way. There's many other ways. Whatever way works for you. I don't really care. Okay, I just need you to be able to solve it. Right? So we know that this is outside the domain, outside the domain, outside the domain, within, 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 within. So your final answer is pi and 6, 11 pi and 6, 13 pi and 6, 23 pi and 6. So far, so good? I'm going to pause the video and I want you to have a go with the next example. Same style, come up with your own strategy, or you can use my strategy. Find first 2 solutions and then use the period if you like, or you come up with your own. I don't care how, but you have to get the right answer. All right, here we go. Try this one now. So this one has a dilation factor and a translation. Get this one right. Continue recording. Here we go. So I'm assuming... Thanks, team. Quiet down. I'm assuming that you've done the first bits no matter which way you did it. You would have figured out sine inverse of half should be in pi and 6, 5 pi and 6. So you got 2 solutions, possible solutions. And from here, I was going to guide. If you're wondering why I took out the 2 as a common factor, I just do that because I like to get rid of the 2's first. That's all. That's just my own preference. I mean, you could have kept it as 2x plus pi and 3, move pi and 3 over. Doesn't matter. Yeah? Have your own preferences. For me, I hate that 2, so I get rid of that 2, and I get x plus pi on 6. Divide both sides by 2. So divide that by 2, that cancels out. Divide this by 2, and you should get pi on 12, 5 pi on 12 as possible solutions. But remember, there's a translation as well. So now I say, let's take away pi on 6 on both sides. But since that's a denominator of 12, I'm just going to change that to a denominator of 12. So that must be minus 2 out of 12. So minus 2 out of 12. So all I'm thinking is, okay, I'll just take 1 take away 2, and then 5 take away 2. Right? This cancels out. So my 2 possible answers with the dilation and with the translation should give me negative pi on 12 and 3 pi on 12. Right? in just the way I taught you before. You do it any other way, but if the easiest way I found was, you find the first two, add and subtract your period. Now the period was 2 pi on n. Since n is 2, it's 2 pi divided by 2, so it's pi. Since I've got denominator of 12, let's just change that to 12s. So that becomes 12 pi on 12. That's equivalent to 1 pi. So now I know all you have to do is just add on 12 and subtract 12. And then you can find all the other possible solutions. So here, that's what I would do. Negative 1 plus 12 is, what's that? It's 11 pi on 12. If I add another 12, I get, what's the other one? 11 plus 12 is 23 pi on 12. If I add another 12, I get plus another 12 is 35 pi on 12. Right? And then clearly the difference between these two is just 4 units. So that means 11 plus 4, that must be 15. And then plus another 4, 27. And you can go backwards as well, but since the domain was 0 to 2 pi, I'll probably stop there and just have a look. 0 is somewhere here. 4 pi, 2 pi, which is 24 pi on 12, somewhere here. So my answers must be these 4. Obviously, you have to simplify your fractions where you can. So your final answer should be x is equal to 3 pi on 12 is pi on 4, 11 pi on 12, 15, so that's what, 5 on 4, and then 23 pi on 12. Hands up if you got that correct. Okay, good. Hands up if you know how to do that on your CAS as well. Okay, everyone, not everyone. Okay, so let's do it on our CAS, just in case you don't know how, so you can check your answers as you go. Let's go to the CAS. Menu 3, 1, so solve. Sign is just next to the trig button here. There's a trig button. Sign of, what's the sign actually? Oh, it is, yeah. 2 times x plus pi on 3. Solve for x. Close brackets. Remember, you have to give it a domain. So this is the, actually no, it's meant to equal to something. What was it again? 1 and 2, yeah. 1 over 2. Okay, so this is the equation, but if you don't give it a domain, you can't solve it. So you're going to give it a domain, and you give the domain not inside the brackets, but outside the brackets. Go control equals to say given, so the vertical line. Control equals, we know that we have to use standard notation here. So 0, x is greater than or equal to 0, and x is less than or equal to 2 pi. I mean, you can press the button pi, but it's easier for me to type pi. So if I press that, if you're in exact mode and radian mode, check your mode. If you're in degrees, they'll be different. And that's what we get. 9, 4, 11 pi, 12, 5 pi, same way. Okay? That's the skill for 6E. So to do 6E, you have to know your exact values, symmetry properties, and then now I'm applying it. That allows you to find axis intercepts later on. And then so next week I can sketch. Okay, so I'll teach you how to sketch, and one of the easiest ways to do it. All right? There we go. That's it for 6E team. The rest is literally a calculator. You can do what I just taught you there. Or you can use symmetry properties as well. It doesn't always have to be an exact value. It can be a decimal. Same concept. Okay, so it doesn't have to be half. It doesn't have to be 0.5. It could be 0.6, but still you got to use the unit circle. Okay? All right, team, we're going to stop the video there.